Discussing about the laws of vibrations of the stretched string. In the previous lectures, we learned about what are stationary waves, graphical representation of stationary waves, analytical treatment of stationary waves. In this lecture, we will see what are the laws that are associated with the vibrations of the stretched string. We know that in the normal mode, or what the fundamental frequency, nu is equal to 1 upon 2L root of T by M, where L is the length of the stretched string, T is the tension in the string, and M is the mass per unit length. The laws are, first law is law of length. The law of length is that the frequency is directly proportional to 1 upon L, or we can say that nu is inversely proportional to the L. But here T and M are constants. Keeping the tension constant and mass per unit length constant, the frequency of vibrations in a stretched string is inversely proportional to the length. This is the law of length. Second one, law of tension. So nu is directly proportional to the square root of tension, keeping M and L constant. This is the law of tension. It states that the frequency of the fundamental mode is directly proportional to the square root of the tension, provided mass per unit length and the length of the stretched string are constants. And similarly, the third law is frequency is inversely proportional to root of mass per unit length. This is called as the law of mass, provided here T and L are constants. So the law of mass states that if the tension and length of the stretched string are kept constant, the frequency of the vibrations is inversely proportional to the root of the mass per unit length. Now we are having two more laws which are derived from the mass per unit length. What is mass per unit length equal to? That brings us to the laws of diameter and density. We know that it is mass per unit length, so mass per unit length should be equal to volume of unit length. Volume of unit length into density. Now we know that volume is equal to area into length. Area is equal to pi d square divided by 4 if d is the diameter, and unit length is equal to 1 and rho is equal to rho. So this is the mass per unit length. Mass per unit length is the mass of unit length of the string. That is equal to volume of unit length into density. Volume is equal to area into length, length being 1 meter, into rho, that is the density. Now, putting the value of M here, it becomes nu is equal to 1 upon 2L root of T divided by pi d square divided by 4 into rho. This 4 is brought to the numerator, so 1 upon 2L root of 4T divided by pi d square rho. Now when 4 comes out of root, it becomes 2. When t square comes out of root, it becomes d. So nu becomes 1 by LD root of T by pi and rho. Now we will come to the laws of diameter and length. From this equation, it is clear that keeping the tension, length and the density constant, frequency is inversely proportional to the diameter. This is the law of diameter. And keeping the length, diameter, tension constant, frequency is inversely proportional to the root of density. This is the law of density. This is the law of diameter. Hope you understood.